Hey, everybody. So today we are going to talk about Revit, some of the primary concepts, fundamental concepts of Revit, and building information modeling, as well as introduce you to the user interface and how do you just like kind of get started in Revit. So, what the heck is building information modeling? So, in the past, when I started in architecture, basically we had to draw everything by hand. And I say that saying that we had to draw everything with AutoCAD. Um, in a way, it's by hand because we had to draw every single component, every single line in a document set. Whereas, say, with something like Revit, we're actually building a model. We're doing it three dimensionally. We're doing it all digital, just like we would we're doing with AutoCAD, but we're actually doing everything in 3D. Now you can do 3D in AutoCAD, but when I was in the industry, the primary method for producing a construction document set was AutoCAD 2D, strictly 2D. So with building information modeling and with Revit, we're designing a model. We're producing a three-dimensional model of a structure, and then we're sharing that model, say, with our other consultants on a project. So let's say the architect is the keeper of the central model, and then they're going to send that to the structural engineer so they can do their design work. And they're going to send it to the MEP consultants or the landscape architect, and anybody else that might be involved on the project, construction manager. So, and as the architect develops the design and the product and the project goes further, they send revisions of that model to these different industries, and then they all send their revisions back to the architect, and we link up into one centralized model where we can see everything in there, the structure, the mechanicals, everything. Now, not all projects go that direction. Some projects, maybe the architectural and structural are pretty much doing the BIM thing, but maybe the MEP consultants don't. They're not going to. They're going to kind of come in later on the project. So it all depends on who's involved in this centralized model at what time. So that can shift. Every project is different. So why would we want to do it this way instead of, drawing everything by hand? First off, and when I say by Wendell's here, when I say by hand, I'm talking about AutoCAD. But first off, when everybody's in their own silo, working on their own thing, structural engineers doing their drawings, architects doing their drawings, there's a lot of room for mistakes, a lot of room for inaccuracies, and things just not quite lining up correctly. Whereas if we have a digital model we can share, we can just say, yeah, this is exactly what the situation is. Design your structure according to this. And with AutoCAD, we would do a lot of file sharing, but it was definitely more siloed. So that's one benefit where we can really just share this model with everybody and get everybody on board on the same page from the get-go. And they can see real-time changes. So if I change something in the model and they're linked up to the central model, they can see the change right away. Or I can send the change directly to them and say, hey, here's our new central model, get rid of the other one. A lot of different ways that teams collaborate. And that's something I think as you go out in the field and you're learning and you're working with people, you just get a feel for that. But I think the main benefit of Revit and its use of the model versus saying 2D sort of documentation is it gets rid of a ton of repetitive tasks. So there's so many repetitive tasks when you're working in AutoCAD, especially within annotation, moving drawings around different sheets, forgetting to change page numbers and tags, and nothing is sort of linked together like everything is in Revit. Revit, everything's linked. So if I move this drawing to this sheet or move it to that sheet, everything gets revised instantly. Okay. And I don't need to think about all those things and hold those things in my head, which ends up just making a problem for everybody. So Revit really did take out a good chunk of headache from taking a structure and putting it into construction documentation. Okay. So I have a lot of respect for it in that way. Now, I will say that Revit tries to do everything, and some people treat it as if you're not doing Revit, you're not doing architecture, but I don't like thinking about it like that. I think Revit's a really good tool, but it doesn't produce the architecture. It doesn't produce the design. It just helps us get there. You'll see some Revit fanatics out there that sort of treat it like it's the end all be all. And there's a lot of other programs out there that do really interesting things better. This one kind of does it. It basically produces construction documents extremely well, and a lot of the industry is using it. Okay, now, is it a good render engine? Let's say, for example, to produce really good imagery of your designs. I would say no. There's way better ones out there, but it does have that capability. Does the good render engines out there produce good construction documents? No, Revit does that very, very well. So they went all in on that, and plus it also tries to. I think it does a lot on construction documentation, and it does a little bit of all these other things. So just something to keep in mind. I certainly appreciate the program and what it does, but I would say it's not so much a designer's tool. It's more of a project architect, construction manager's tool, which there's nothing wrong with. That's just I come from a design world, so it's just something, it's not a gripe I've had with it, but it's just something I have to work with. Okay, so that's kind of the basics. I think what I just want you to make sure you understand about is this idea of a centralized model that multiple people can work on at once, which we will do in this class, and that it updates constantly. And we don't need to sort of constantly be sending files around and making sure I have the most up-to-date one when I can just reload the central file and get any updates that are out there. So that's really the biggest concept that you got to kind of keep in your head. So I have a handout I'd like to discuss a little bit. That's this one. Now the class up there says ARC Software 2, which some of you are in, and some of you are in my electrical and mechanical class, but all this information here is for both. So a couple basic concepts. There's 3 fundamental types of elements that we use in Revit. We use model elements, datum elements, and view-specific elements. Now, model elements you can just think of as things. Walls, floors, stairs, doors, all these things, architectural components. Those are just model elements. However, some of those model elements are host elements, like walls, floors, ceilings, slabs, and roofs. Okay, now what do I mean by a host element? That means, like, take a wall, for example. It can host other model components. It's going to host doors, and it's going to host windows, for example. Whereas a door and a window can't host anything. Okay, so that's the difference between those two. But I just like to think about it as model elements are just the things. Okay. Datum elements are basically like wayfinding elements within your Revit model. Structural grid lines, levels, like what in elevation drawings, what levels are we on? Where are the levels in the building? Is it 10 feet from level 1? Is level 2 10 feet from level 1, or is it 20 feet? So that's what levels are. And then reference planes, just planes that we can sort of access to help us draw different things, do different things. So these things aren't actually things in the model. They're just imaginary lines, imaginary reference points, if that makes sense. And then we have view-specific elements, which are basically, if I have a view of the floor plan, okay, so I have my model, okay, and I want to look at level 1 floor plan, I'm going to go to a view of that. Okay, we're looking at the same model though. Every view we have, elevation, floor plan, section, whatever the case may be, they're all just views of the same model. If I go to one of those views, I can have different annotation elements on that view. For example, room names, dimensions, any sort of text or notes, or any sort of details. Those will only live on that view. They don't live in the model. They're just a view specific element. That's what they are. So if I go to the next view, I'm not going to see those. I will see the datum elements and I will see model elements, but I won't see any view specific things that I put in this drawing versus this drawing. You'll get what I'm talking about as we dive in. Now, of those 3 fundamental elements, there's 3 ways to sort of manipulate everything. So there's 3 ways that we can manipulate model elements. We can manipulate datum or view specific elements. And we do that through views. So I can go into a view like the floor plan. I can move a wall. I can move a window. I can move a door. I can move a grid line. I can change any of the annotation elements on that drawing. Okay, so that's one way to manipulate those 3. I can change information in schedules. So a schedule, let me give you a very simple example. There's with every project, there's a door schedule. So a door schedule is a fancy way of just saying spreadsheet. It's a spreadsheet with information about all the doors in the project. Now, if I deleted a door off the schedule, it would actually delete it in the model. So they're linked in that way too. And likewise, with sheets, I can go to any sheets I have set up, like floor plan sheets, elevation sheets. I could go to an elevation sheet. An elevation sheet will have one view on it or multiple views of elevations. And I can go into that view through the sheet and manipulate the model. So that might get a little heady, but those are the different ways that we can sort of manipulate this centralized model that everybody is sort of connected to. Now, as we work through this course, it's really going to be just you working on one model. And then at the end of the course, we're going to do some work sharing so you can get the feel of that, what it's like where you have somebody working on this part of the building and you're working on this part of the building, but it is one model. So at the onset here, we're just going to sort of get our bearings in Revit and sort of kind of each play with our own design. Okay. So I hope that was clear, but that's just sort of a good introductory kind of map of where we're headed and what Revit is. Just keep in mind that centralized model. Okay, so I'll stop this video and then I'll start up another one for the user interface. So stay tuned for that lecture.